Hi everyone, this is Dr. J. Nirmala Devi, Associate Professor from the Department of Information Science and Engineering. In today's session, we are going to discuss about an important problem in process management. We know that there are n number of processes that will be running in a computer system at a time. And these processes always require set of resources for completing its execution. The operating system has the responsibility to allocate the resources that are required by the processes. And the resources may be a memory, a printer, sometimes a file, and so on. If suppose the resources are not free, the operating system could not able to allocate it to the processes. That time, the process has to wait some amount of time for its execution completion. In some cases, there are more number of processes arriving all the time to the system, and the operating system could not able to allocate the resources to the processes, which leads to a problem. In today's class, we are going to discuss about what is that problem is called as and what are the conditions in which that problem is occurring in the system and in what way we can identify the problem has occurred in the system. Now let us move on to the session. Let us start the session with an introduction. Here we are seeing a picture of a traffic jam. The traffic jam has been created because a vehicle has been stuck in between the roads, so that the other vehicles which is coming from different lanes could not able to move towards their required destination. Since because of this it has created a traffic until the vehicle which has stuck in between has been released or moved to some other position, the vehicles cannot move forward and the traffic could not be cleared also. So this is a situation. Keeping this in mind, we are moving to a scenario of an one-way bridge. So in this one-way bridge, only one vehicle can cross at a time. No two vehicles can cross. Suppose we are considering that if one vehicle on the left direction and the other vehicle on the right direction is trying to cross the bridge, only one can move. Unknowingly, if two vehicles has entered into the bridge, no way it can move to the other side. It got stuck in between. So in this situation, either the blue car or the yellow car which is seen in the figure has to go reverse and give the space for the other vehicle. Otherwise, the vehicle which is stuck in between could not be moved. Also, the vehicles which are behind these vehicles also could not be traveled on the one-way bridge. So this situation where we are getting a struggle of moving the cars on the either side, what happens is that a situation deadlock will occur. This situation of deadlock in case of computer system is nothing but when a process are requesting a resource and the resources is held by another process, then a situation like a deadlock will occur. Now, keeping this in mind, we go on understanding what a deadlock is. The definition of the deadlock says that a deadlock occurs when a process or thread enters a waiting state since that it is requesting a system resource which is held in by another waiting process, and that waiting process is also waiting for another resource held by another waiting process. In simple, we can understand that when two processes are trying to get a resource which is held by another waiting processes, thus a deadlock will occur. So in the figure, we are seeing that two persons are trying to grab a book. So the book cannot be used by two persons at a time. Either the first person, after reading or writing the book, can give to the other person so that the other person can use the book. So this situation, when trying to grab one particular resource by two processes, is called as a deadlock. Now we go to a scenario 2. In this simple scenario, we can understand deadlock even better. Here, Amy is a person who is trying to make an omelette for breakfast, and Amy tries to get the oil to start cooking. And at the same time, Adam is trying to make a pancake. Adam grabs the pan. Now, Amy won't release the oil till she gets the pan. Same time, Adam won't leave the pan till he gets the oil. So this situation will create a deadlock. Why? Because is that Amy needs a pan and Adam needs the oil. So this situation could not be solved until any of the person is leaving the resource to the other person. So this situation is also called as a deadlock. Now let us move on to understanding the modes of operation, how a process is requesting a resource. Normally The mode of operation for a process to utilize the resource is of three ways. One is first request the resource, then use the resource, finally release the resource. The first thing is requesting the resource. So the process when starts requesting the resource, if the resource is available, the resource may be granted by the operating system immediately. If the resource is used by another processor, the resource cannot be granted. That time, the process may wait for the resource. For example, if we have set of processors and they are trying to access the memory, if the memory is free, then the memory may be allocated to the process. If the memory is not free, the process has to wait until the memory is getting free. For example, when we use a Google Sheet or something like a shared memory concept, so the memory may be utilized by only one process at a time. So until it completes its writing or reading operation, no other process can use the same memory location. So this is what about the request. When a process requests, it has to wait for the resource or immediately it may be granted. That will be decided by the operating system. The next mode is about the process use. How the process use the resources. So here we are seeing that we have a printer. The printer, if suppose the process is requesting a printer as a resource and it needs to print a file, it will be using the resource for its work completion. The same time, if the process is trying to access any of the system resource also, it may utilize it and it can access on the file or it can save the file or it can work on the file, and after completion it will be releasing the resources. So that is what called as the release. Once the process get finally completely utilizing the resource, the process will release the resources. So these are the three modes of operation by any process on requesting, use and releasing the resources. Now we go for an example for understanding the deadlock even better. Let us consider that we have process 1 and process 2 and we have resources printer 1 and print DVD. Here we are seeing the image that where the process 1 is requesting a printer and the printer is already allocated to process 2, and process 2 is waiting for a DVD and it is already allocated to process 1. So the situation clearly shows that the process 1, which is having a DVD resource with itself, is needed at the printer resource to complete its execution. At the same time, the process 2, which is having a printer resource with itself, needs a DVD resource to complete its execution, which leads to a deadlock. That means either process 1 or process 2 has to release its existing holded resource by itself, has to be given to the other process to complete its execution. Now we go on understanding what are the various necessary conditions a deadlock would occur. So we have understood that what is a deadlock. Because of the resources held by the other processes, the resources cannot be accessed by the required process. So the process has to wait for n amount of time. So in order to avoid that, first we have to understand what would create this deadlock situation. So the necessary condition for a deadlock occurrence in the system is mutual exclusion, no preemption, hold and wait, and circular wait. First, let us understand what is this mutual exclusion. So mutual exclusion is a condition if suppose we are having a 4 telephone booth and if it is free, anyone can use it. So since it is open is mentioned in the figure, we can understand that it can be accessed by any person. Now let us consider one person has used the first booth, then it means that closed. No other person can use it. The other person can occupy the remaining 3 telephone booth and they can use that. So since it is open. So if the next person is entering it and now we can see that the 3 booths are occupied. Only thing left is the fourth one. If suppose the fourth one is occupied by another person, it will also get closed. In this situation, if suppose a fifth person is trying to enter, only when the person who is inside the booth is releasing or coming out of the booth, the fifth person can enter. So this is what called as a mutual exclusion. Mutually, they are coming to understand that somebody is waiting outside. They can come outside and give the telephone booth to the other person. The same way, each and every process has to understand by itself and it has to release the resource for the other process to complete. But normally, this won't occur. So this is what called as a mutual exclusion. The next we move on understanding hold and wait condition. In this hold and wait, we are seeing in the figure we have two process P1 and P2, and we have resource R1 and R2. It's clear that the process P1 is requesting a resource R2 but it is holding and resource R1. The same way, the process P2 which is requesting a resource R1 is holding a resource R2. So each process is holding a process by itself and again it is requesting. This situation leads to a deadlock. And the circular wait means that here we are seeing there are n number of processes and n number of resources. So the process P1 is requesting a resource and the Pn is allocated with that resource, and the same way P0 is requesting resource R0 which is allocated to P1. So which creates a circular request. So we can understand this with an example where we are having a resource R1, R3 and R2. R1 and R3 are a single instance. The dot here of black is saying that R1 is a resource which is having a single instance. That means only one instance of that particular resource is available. And R2 is a resource which is having two instances. So with this, we can see that the P1 is requesting R1, R1 is assigned to P2, and P2 is requesting R3, and R3 is assigned with P3, where P3 is requesting for an R2 resource. So since the R2 resource, two instances there, one is already allocated with P1 and P3 is also requesting an R2, it can be given. But a circular wait condition is occurring here. So which creates a deadlock. Until one process is getting released with the resource cannot be allocated. So these are the four necessary conditions where a deadlock is occurring. Now let us understand how the deadlock can be identified in the system. This can be done using the resource allocation graph. What is this resource allocation graph? The resource allocation graph is the one where a deadlock can be described in terms of a directed graph. So using this directed graph, the system and resource allocation will be mentioned in the graph, and we can identify based on the allocation whether the deadlock could occur or not. Here we have set of vertices V and set of vertices E. The set of vertices will be of two nodes. One is for the resource, another one is for the process. If suppose we are having process P1 to P1, the set of processes which is available in the system that can be mentioned in the graph. And R1 is nothing but the set of resources available in the system. It may be from R1 to Rm. And when we have something like Pi is assigned to Rj, which is nothing but process Pi is requesting a resource type Rj. And there is an indication something like Rj is indicated with Pi means that the particular resource type Rj has been allocated to process Pi. Now here we are saying that the Pi to Rj is nothing but a request edge, and Rj to Pi is nothing but an assignment edge. And now we move on understanding the representation of the graph, where P1 is indicated with a round blue circle, which is nothing but a process. And we have a rectangular shape of resources which has a three dots is nothing but the instances of a particular resource is mentioned this way. Let us take an example. We have process P1 to P3 and resources R1 to R4, and we have set of edges where P1 is assigned with R1 and P2 is assigned with R3, and the resources R1 is assigned to P2, R2 to P2, and R2 to P1, and R3 to P3. In this situation, we could able to understand we have four set of resources and a set of edges, and all these edges are saying that how the processes and resources are allocated with each other. With this, we have a resource allocation graph now, which is represented with the various processes and resources available. And here the R1 is a resource which is having an one instance, and R2 is a resource type which is having two instance, and R3 is a resource type having one instance, and R4 is a resource type having three instances. And now the process P1 and P2 is requesting the resource R1 and R3 respectively. Also, the resource type R2 is assigned with P1 and assigned with P2. Means that
the two instances of R2 type has been one assigned with P1 and the other one is assigned to P2. Now we can see that the resource type R1 is assigned with P2. The same way R3 is assigned with P3. Now we have to go for understanding whether the conditions for deadlock has been occurred in the resource allocation graph or not. Here we know that the conditions for deadlock is mutual exclusion, hold and wait, no preemption and circular wait. So the mutual exclusion is occurred here. Why? Because is that the process which is holding a resource cannot give that resource to another process until it completes its execution. The same way, the process which is holding the resource cannot release the resources and since it is waiting for another resource for completion. For example, let us take the process P1. The P1 is assigned with R2 resource but it requires an R1 resource which is holding R2 but it requires R1. So hold and wait conditions also satisfied here. And the preemption, no preemption means that the process cannot be released by a process and can be given to the process again. It cannot be preempted. So that condition is also satisfied here. The fourth condition, circular wait, is not there. But let us take process P1. The circular wait condition is not obtained. Why? Because is that the P1 is requesting R1 and R1 is assigned to P2 and P2 is requesting R3 and R3 is assigned with P3. So there is no circular wait in the process P1. The same way, the circular wait is not in for process P2. Means that P2 is requesting R3 and R3 is assigned with P3. The same way, the P3 is also circular wait is not there because the P3 is a process where it is assigned with only resource R3. Now, the no deadlock has been occurred in this resource allocation graph. Why? Because is that three conditions has been satisfied by the processes, but the fourth condition, circular wait, is not satisfied. Let us modify the graph and see that whether the circular wait is occurring in the graph. Let us modify the graph by making that the process P3 is requesting resource R2. We know that R2 is a resource type where it is having two instances and one is assigned with P1, other one is assigned with P2. Means that the process P3 cannot execute its completion because it is requesting a resource R2 which is already holded by P1 and P2. If any of the process P1 or P2 is releasing the resource, then only P3 can use it. So a circular wait condition is occurring here. So which leads to a deadlock. So thus using this resource allocation graph, we can understand that the process P1 and P2 will creating a circular wait condition which leads to a deadlock occurrence. So in the summary, we can understand that using the resource allocation graph, if it contains a cycle, then the system is in deadlock, and if it is does not having a cycle, then the system is not in a deadlock state. So the cycle formation can clearly indicate that a deadlock will occur in the system.
Thus, in today's class, we have seen about what is a deadlock, why the deadlock has occurred in the system, and what are the necessary conditions for the deadlock, that is your mutual exclusion, hold and wait, no preemption, circular wait. So when these four conditions are occurring in the system, we can say that there is a deadlock in the system. And we have seen that what is a resource allocation graph. It is a pictorial representation where we can see how the resources are allocated to each processes. If there is a circular or a cycle is forming in the resource allocation graph, we can come to a conclusion that a deadlock will definitely occur in the system. That will be based on the number of instances of a particular resource type. So that's all about today's session. Thank you.